So for this question, we have a steel ball of mass m1, 4 kg, moving with the initial velocity u1, 4.5 meter per second, collide with a wooden ball of mass m2, 2.5 kg, which is initially at rest. Initially at rest telling you that the initial velocity for ball 2 will be 0. After the collision, both balls deflect with an angle 30 degree. What are the final speed of the two objects? Means what is the final speed for ball 1 and also final speed for ball 2. So I denote it as V1 and V2. So you can see obviously this is a 2D collision, oblique collision, whereby the ball will move horizontally and vertically after collisions. So in order to solve this question, first we need to break the velocity into x and y component, and always bear in mind velocity is vector quantities, so we need to include the negative sign for the leftward and downwards directions. Then only we can write the conservations of momentum for the x direction and y direction separately. So first we break it down. So for the initial, before collision, the initial velocity for the first ball is only have component x. This will be our u1x is 4.5. The u1y will be 0. Same goes for ball 2 because before collision ball 2 is at rest. So the component x for u2x is 0. Same goes for u2y is 0. Then how about after collision? After collision V1, ball 1 is moving off at an angle 30 degree. So V1 I can break it down into two components. This is the direction of V1, ball 1. So I can break it down into V1x, which is equal to V1 cos 30. Why 30? Because V1x is adjacent to the angle. Then I have V1y will be V1 sine 30. Same goes for V2. I can break it down into two components, V2x and also V2y. So this is the direction for the second ball, 30 degree. So the 30 degree will be here. So I'm going to have V2x will be V2 cos 30. Why cos? Because this component is adjacent to the angle. Then V2y will be V2 sine 30. But then, be careful. The component y for the ball 2, V2y is acting downwards. So we should add a negative sign. So don't forget the negative indicates that the component is downwards. Okay. After we have break down all the velocity, then only we can write the conservation of momentum for x and y direction. So we consider the x directions. So we have total momentum x before collisions equal to total momentum x after collisions. So before collisions, m1, mass 1 is moving with a velocity 4.5 meter per second, but ball 2 is at rest. After collision, m1 is moving with the horizontal component v1 cos 30 and m2 is moving with the horizontal component v2 cos 30. So we are going to have 4.5, the mass is 4 kg for m1. The initial velocity along x direction is 4.5 plus the mass for the second ball is 2.5, but before collision is not moving, so 0. After collision, ball 1, 4 kg is moving with a velocity v1 cos 30 along the x direction, plus with ball 2 is 2.5, move at a velocity v2 cos 30 along the x direction. Now try to simplify it. 4 times 4.5 is 18. So equal to 4 times cos 30 is 3.464 v1 plus 2.5 times cos 30 is 2.165 v2. But since I have two unknown, I cannot solve it, so I put it as equation 1. Now we consider the y directions. The total momentum along the y direction before collision must also equal to the total momentum along the y direction after collisions. So before collisions, you will notice that the ball is not moving along the y-axis. Anyhow, after collision, ball 1 is moving along the y-axis with a velocity v1 sine 30, and ball 2 is moving along the y-axis with a velocity negative v2 sine 30. So we are going to have 4 times 0 plus 2.5 times 0. Again, y0 because before collision there is no component y. The two object is not moving along the component y. Okay. After collision, we have v1 sine 30 and negative v2 sine 30. So we have So equal to, after collision, for the first ball, 4 kg moving with a velocity v1 sine 30 along the y-axis plus second ball mass is 2.5 moving with a velocity negative v2 sine 30. Okay, so again I solve it. So this one will be 0. 4 sine 30 is 2v1 minus 2.5 sine 30, 1.25 v2. This will be our second equation. Then I'm going to solve these two equations. First equation and the second equations using the simultaneous equations function in calculator. Equations. So we are going to solve for the two unknown in your calculator. So I put in the first equation, the A is 3.464, B is 2.165, the C is 18, then the second equation is 2, negative 1.25, the C is 0. Okay, so I get the first unknown, V1. So the first unknown, V1, will be 2.598, I round it off, 2.60 meter per second. And the second equation, second unknown, V2 will be 4.156, I round off, I will get 4.16 meter per second. Then I have obtained the speed for the first ball and the second ball after collisions. Then the second question asks us to determine whether the two collisions is. Then the second question asks us, is the collision elastic or inelastic? So in order to determine the collision is elastic or inelastic, we need to determine the total kinetic energy before and after collision. Why? Maybe you ask why? How can we determine elastic and inelastic collision? We can base whether our kinetic energy is conserved or not if you refer to your lecture notes. So if the collision is elastic, the total energy is conserved, means the amount of total energy before collision and after collision is the same. But then, if inelastic collision, the total kinetic energy before collision and after collision is not conserved. Not conserved means not equal. Some of the initial kinetic energy will transform or lost in form of thermal energy or sound energy. Okay, so In order to prove that the collision is elastic or inelastic, we need to calculate the total kinetic energy before collision and after collisions. So, boys and girls, before collisions, we already know that the first object is moving with initial velocity 4.5 meter per second, whereas second object is not moving, u2 is 0. After collision, we already calculate just now, after collision, our first ball have a velocity of 2.6 meter per second, and our second ball have a velocity of 4.16 meter per second. So, we are going to calculate the total kinetic energy before collisions. So, how to calculate kinetic energy? So, the formula to calculate kinetic energy will be half multiplied the mass multiplied velocity squared. So, I'm going to have total kinetic energy before collision will be half. Mass for ball 1 is 4.4 kg. The velocity is 4.5 squared. Then there will be no kinetic energy for the second ball because it's not moving at rest. So the total kinetic energy before collision will be back to mode mathematics, general calculation. 0.5 half times 4 times 4.5 times 4.5. So I get 40.5 joule. Then I calculate the total kinetic energy after collision. So after collisions, the ball 1 is moving off with velocity 2.6. Second ball is moving off with velocity 4.16. So they are going to have kinetic energy half. First ball is 4 kg, the speed is 2.6 squared plus half. Second ball is 2.5 kg, the speed or the velocity is 4.16 squared. Then I'm going to have 0.5 times 4 times 2.6 times 2.6 plus 0.5 times 2.5 times 4.16 times 4.16. So I'll get the total kinetic energy after collisions is 35.15 joule. So if we compare the total kinetic energy before collision and after collision, we will find out that the total kinetic energy before collisions is not equal to total kinetic energy after collisions. So this will telling us that the collision is inelastic. Okay, so we can draw a conclusion, the collision is inelastic.